Alright, let me show you the authoring perspective of Sowiso from the authoring environment. So I'll click on the author and it brings me to the author environment where I can create new exercises, new chapters, or any of the other content items. I'll start by the exercise. With the exercise, I'll create a new one. And I'll start with exercise type open, which is for mathematical expressions. I'll give it a name and continue. It brings me to the texts where I see title, question, solution, pre-input 1 and post-input 1, which are all placeholders for the exercise. I can say title, question, solution, something before the input field and something after it. I can save it all, and now if I preview the exercise, you'll see that the title lands above the bar, the question text is here in between, and there's another bar, there's something before and after the input field, and if I hit solution, it will show me the solution text. All these fields can be used to insert mathematical expressions. There are multiple ways of doing so. The most common one is by using LaTeX. If I type something like a fraction in LaTeX, I can use hashtags as delimiters for the mathematical markup and say frac A over B. And if I now save this, it will automatically preview it as a fraction in the preview. There's an alternative way of doing this. You can also use the backslash parentheses as a delimiter for the math mode. And you can, if I save that, I get the same result. Or you can use a square bracket to get horizontal alignment. Which is especially nice if you want to emphasize certain mathematical content. You can also use environments like arrays and tabulars or matrices. And for those that do not know mathematical markup language LaTeX that well, you can use ASCII MathML, which has demarcations with the @ symbol. So here I can do A/B, and that will give me the same output as A over B. Although ASCII MathML is quite simple to use, it has its limitations, so therefore we support both. If you as an author don't know how to write LaTeX, you can go to the X squared, which will bring you to the formula editor. And right here you can use the graphical formula editor that students also use and put in an equation, which will get translated for you, and then here you'll have the LaTeX variant. As you can see, the hashtags frac A over B is the same as I used over here. You can copy and paste this directly into this field, and that way you don't really have to know your LaTeX that well. So let's make a real exercise out of this, where we put some randomized values in there. So I go to variables and I add 2 variables, or maybe 3, which I randomize. I say randomize 2 to 8, which is a PHP function. We use PHP as a language for the variables names, for the variable definitions. And I now have a randomized value there. I'll make another one as $B, and then as $C, I'll add those 2 up. I made a mistake here, and the system actually points me to the right direction. I have to use A here, not C. Right, so when I have a preview value of 2.8, which adds up to 10, I'm going to make a addition question out of this. And I can use those dollar values that I just used in the variables here again in the question text. So here's my question. Let's write the solution as well. And we can have a preview to see how it looks like. It looks good. This also looks good. All right, the next step is to make sure that the correct answer will be accepted as the correct answer, and we do that under solutions. We still have to input the solution here, and if we do so, then the final answer of 10 will be accepted. There is one last thing we need to do, and that's because we actually accept mathematical expressions as an input next to numeric expressions, the student right here could just repeat the question. Because we don't want this, we have to put in a rule that stops the student from being final or finished and tells the student that still something needs to be done. We call those rules positive feedback rules, which means that the answer was already accepted as correct, but there still needs to be done something. In this case, I'll apply a rule which is called is not an integer, which means that the answer must be in the form of an integer. Only then will it be accepted as final. So let's see if this worked. Yes, this is exactly what we want. The answer is correct, but it's not final yet, so the answer must be in the form of an integer. If it complies to that rule, we're all done. And now our exercise is ready. We can also give negative feedback, which kicks in when the answer is not correct. So for instance, if we have a value of c here with a precision of 1, which means everything of 1 around the correct answer, we can give the feedback that the student is almost correct. Let's see that into action again. 5 plus 6. So let's be 1 off. And indeed, the answer is wrong, and I get the feedback that I just typed in, almost correct. Also, if I'm 1 off in the lower bound, and if I get the final solution, I'm still done. All right, I now navigated to creating a new theory page. As you can see, I have just one text editor here, which is my canvas to write on, and I can just start typing. I can use math mode the same way as I do in exercises. And I can also create the cards or use images. If I want to create a card, I can select the text, go to Format, and say I want to have a theory block definition. If I save that, oh, it ate up my spacing. I can preview it, and this is the way it comes out. I can also insert an image. If I go to the General tab, I can add a file here, maybe this histogram. If I just upload it, I can now go back to my theory page, and I can go to Insert Image and pick this one from the source list. I can add some extra dimensions to it if I want, but if I just insert it, it will show it as is. And I can even draw the corners to make it larger or smaller if I need to. If it's too small but you do need the space, you can actually go back to the image view, give it a zoom class, and that way the students can hover over it. They will see a magnify glass. If they click that, it will zoom in. You can also undo. So if I undo this, I get the preview of the image back normally. I can also embed things here, like YouTube videos or other things from the internet, like GeoGebra applets. GeoGebra applets can be done by going to Insert GeoGebra, and then here you can put in the material ID, and embed codes from YouTube, for instance, can just be pasted into the source. So you can just paste the code here under. And this source code editor can always be used if you need to go to the source of the theory page itself. Other than that, there's default functionality for alignment, bulleted lists, bold and italic content. You can cross-link to other theory pages or other places on the internet. And you can also add tables very easily by using the table column chooser, column and rows chooser. There's also a possibility to embed iframes or to use our default two-column split for definitions, where you can choose between the ratios 60-40, 55-45 or 50-50 to place two pieces of content next to each other on the screen. Next to the definition, it's also possible to make something an expandable box. It's quite easy. You just go to theory format again, and then to theory expandable block, and then you choose more, proof, advanced, or explanation. So let's choose more. Now this second text, the more, is conditional. Only when the student clicks on more, you will get to see the definition. It's also possible to change that text. Instead of where it says more, you can also say maybe image. You can just select that text and mark it as a block header. If you do that, image will get replaced into the more title, and then the name of the expandable block will now be image. The way the Sowiso content or system is structured is displayed in this diagram. On the right hand side you see the world of the users, and on the left hand side you see the world of the content. Users can have different roles like student, teacher, author, or admin. They are collected in a class, and a class is attached to a school. Then the teacher decides on class level what chapters are available in his class. The chapters are written by the authors, and they are belong to an authoring group, as do the exercises and the exams, which means that all content items are somehow linked back to an authoring group. Then the way we set permissions in the system is that authors are also part of the authoring group, and there can be multiple permission levels. If the author doesn't have any permission, you won't see the content in the authoring environment. If he has read and copy permission, he gets to see all content and he can copy it to his own authoring environment, authoring group, but he's not able to edit it. So he just has read and copy rights. Then if he has write access, he can actually edit everything and also delete and change everything. And then there's translation options and write not publish options for some specific cases. if you would want to collaborate with others, setting up a specific authoring group for that makes a lot of sense. That way you can yourself determine which part of the content you share and which part you don't. Our Sowiso pre-made material is all part of authoring groups that are linked one-to-one to a product. If you get a license on one of those courses, you will get read and copy authoring permission on that content, which allows you to copy over the content to your own authoring group, and then you can change everything within that content what you like. We do have one smart trick there, which is that if you actually copy a chapter, it copies the chapter structure, but not the content itself, which are the theory pages and the exercises. That way, only if you explicitly detach your content from our structure, until then, any future improvements that we make on the content, you will still benefit from them. Alright, I switched back to the authoring environment, and I'm now looking at the course in the authoring group SW Basic Math, and also authoring groups have the prefix SW. If I look into the course, I see it consists of these chapters, and if I'm, for instance, interested in one of these chapters, say algebra, I can now copy this content to my own authoring group to start editing it. I can just click copy, select the target authoring group, demo, and then I can select content items. I can select everything or maybe just parts of it. If I hit copy, a copy will be generated for me, and everything will be visible in the authoring environment later on. So I now have my own chapter algebra, which is part of the demo authoring group. And from here, I can start editing all material. If I edit the theory page, you can see that there's still a back reference to the original content. That way, I get all future improvements on this theory page that Sowiso will make. If I don't want that and I want to put my own text in here, I can just detach this, and now I can start editing this. I can change the values, and from now on I've created a real proper copy of this theory page. Same applies for exercises. I can now add new exercises to this particular package, maybe remove exercises, or just add exercises from my question bank that I want to be in there as well. I can also reorder the content by drag and drop here. So by creating a copy of the content, you get full control over your chapters and the content in those chapters.